Welcome to Chatting with Chuck. I'm your host, Chuck. Today, I want to apologize. I'm a little under the weather, especially a week before the holidays, which kind of throws things off. But I want to go ahead and talk about automation dashboards today. I've had some questions on automation dashboards, so I thought I'd just talk a little on those. So let's jump right into it. And if I sneeze or cough or something like that, once again, I apologize, but try to get through this. So let's talk about this. Let's talk about supervisory control and data acquisition, also known as SCADA systems. Software and hardware are used in automation and control in electrical power, chemicals, oil, gas, food, beverage, manufacturing, and all kinds of industries. That is because SCADA solutions offer such benefits as real-time detection of machine faults, output defect reduction, and cost savings. In the electrical and oil and gas sectors, SCADA systems reduces loss and optimize production. Thanks to such benefits, SCADA deployments are expanding. Analysts forecast SCADA components to have a compound annual growth of 5.2 to 6.6% over the next 5 to 7 years. Another growing technology is the IoT, or Internet of Things. Tens of billions of devices will be connected by 2020, according to my data from Cisco. The network company says that there will be a four-fold increase in connected devices at the end of this decade as compared to 2010. A significant fraction of these will be in the industrial applications. That means there will be a proliferation of sensors and data, as well as an expanding pool of devices available for accessing this data and exercising control via SCADA. This presents a challenge, but solutions built upon HTML5 technology can overcome them. The result will be a cross-platform viewing of data and implementation of control functions. So what are some of the challenges of SCADA? Well, see why IoT creates issues, for traditional SCADA solutions. Consider how these systems have been designed and deployed in the past. Years ago, control and automation systems were standalone and separate. Often, the critical nature of functions carried out meant that such systems had limited access to the outside world. They also had a designated human-machine interface, or an HMI, which handled nearly all day-to-day interaction between the control and the system operators. To ensure the highest possible system safety, security, and reliability, the HMI might be the only way for anyone but a developer to access the SCADA system. Over time, these systems were integrated into an industrial network that connected everything on the platform. This made it possible for vital data to flow from a factory floor to some other location to a management network and vice versa. Typically, though, the points of connection were strictly limited and restricted, again for safety and performance reasons. Thanks to this setup, SCADA software has traditionally been designed for specific screen sizes and orientations. A designer, for example, may lay out buttons and gauges on a touchscreen that is known to be 20 centimeters or more diagonally, with a fixed aspect ratio between the width and the length. The designer would then place a certain number of items on the screen. The goal would be to maximize usefulness to the productivity of an operator, with trade-offs made between the element size, readability, and usefulness, and resulting HMI complexity. Human factor considerations, such as the size of the fingers and the need for certain button dimensions, also played a role. However, the growing proliferation of connected devices is fundamentally changing this picture. The increasing connection between the SCADA systems and the outside world means the display system is no longer as fixed as it once was. Before, the HMI might run on a screen measuring 18 centimeters or 7 inches on one side, with no other option. Displays used for data viewing and control functions might range from that of a smartphone to a tablet or desktop computer. While smartphone displays have gotten steadily larger over the years, there is still a significant difference in the size of a smartphone screen that can be found versus a desktop. Since this involves displaying information in buttons, more than physical screen real estate is involved. What is important is resolution, and this varies significantly between devices. A high-end phone, for example, may have a screen of 1080 by 1920 pixels, while high-performance desktop systems may have a 5120, or 5120 I should say, by 2880 pixel display. Tablets yet another configuration, as do the phones and the devices. Thus, SCADA now may come use a variety of displays with all differing resolution and orientation. Indeed, the aspect ratio of a screen may change, as happens when a phone or tablet switch from horizontal to vertical orientation or vice versa. As additional challenges arise from the IoT, the Internet of Things means that there may be more sensors with these providing with me critical information of machine health, process conditions, or both. Such data may be what was traditionally captured by SCADA system. However, it is likely that was generated by the sensors will be more extensive than anything coming out of a SCADA setup. This then, given the rise of the second great SCADA challenge, there will be much more data produced by these sensors. This will lead to cross-platform applications to make use of flood of data and create connectivity. Consequently, a SCADA system will find itself in an environment that is much more complex than what has been in the past case. So, SCADA information will be displayed on a wider range of devices than was the case previously. Some of these will be remote and some will come from non-traditional suppliers. Yet all of that, the basic needs of the system must meet and must not change. Their information will still have to be displayed in a way that makes sense to the users. While control and other functions must be carried out, this will have to place in a setting that is more complex and viable than before. So how do we solve this? Fortunately, the new technology landscape contains solutions to such challenges that can also create benefits. This comes from using the power of HTML5. The fifth version of a hypertext markup language standard is the core language of the IoT. Adopted in 2014, HTML5 is important over its predecessors because it supplies the latest multimedia as well as allowing application programming interfaces to become complex web applications. Additionally, it has features designed to make it work better on low-end devices. This includes running and loading faster while allowing for higher quality video and audio content. In turn, this means graphics can be more detailed. Also, the greater the performance means the application will be more intelligent. The power that often gets a further boost because of HTML5 applications are quicker to design and modify. What's more, the debugging process of any application is faster because of the features built into the language. Importantly, for SCADA applications, HTML5 allows the correct scaling of graphic images and text of any orientation screen. This scaling is uniform across them all. What is on a SCADA display needs no longer to be tied for one fixed to a screen layout. What is needed, of course, is an HTML5 capable web browser. For example, for SCADA applications, there also must be enough screen real estate for information to be readable and buttons big enough to be pushed. With the ability to zoom in or out and pan around as needed, though, even small screens can function as large ones. The HTML5 and web access is possible for users to browse and monitor SCADA controlling process using virtually any device at any time and any place. Thus, this solves the problem presented by SCADA displays by a new era of connectivity. However, HTML offers a vital additional benefit. It is a connective link for the Internet of Things. Many IoT devices generate data, with examples being sensors that report the characteristics of vibration of a machine, its temperature, the temperature of the room, the other environmental conditions. This information must be sent to servers, which can distribute the data, for there can be action taken, such as scheduling preventive maintenance for machinists showing signs of wearing down. There must be, however, communication between the data generation and server. What's more, this communication must be full duplex. With such a two-way link, either end of connection can initiate a data exchange. A final key characteristic that must be present is the communication must have low latency and little overhead. These requirements are important in the IoT setting. After all, a sensor generating data may not transmit much or often, but when it does, it needs to send the information. There should be enough area space to do this. The billions of IoT applications that will be connected will not happen without a flexible and powerful connector. The WebSockets protocol built into an HTML5 does just that. Although designed to be implemented in web browsers and web servers, WebSockets can be used by many client or server applications. Using this technology leads to low overhead persistent connection between the client and server, one in which both can start sending data at any time. The capability is a leading reason why HTML5 has become the language of choice for IoT application. What this means is that an HTML5 capable browser and associated software are well suited for the IoT environment. The power of HTML5 makes it possible to easily develop for an IoT application. This could be used, to allow fast and stable integration of third data party, such as information generated by sensors. This makes it feasible to take advantage of the flood of the IoT devices and that they may capture. As it shows, HTML5 solves problems created by SCADA systems by screens by varying resolution and orientation. Additionally, the latest version of hypertext markup language also makes it possible to incorporate information from IoT devices into SCADA scheme, thereby extending the reach of the solution while enhancing its usefulness and values. So what's some of the typical applications? Let's just talk about it. There's examples of how setup would illustrate the advantage of this approach. Typical applications are found in managing factory floor as well as monitoring photo operations of a facility. In the case of the first of these applications, there may be the ability to gather data from sensors allows an HTML5-based solution to improve the effectiveness of factory automation and control. For example, integrating machine vision, motion, and robotics leads to enhanced production with less waste, fewer defects or rework, and tighter product specifications. What's more, additional data and greater connectivity allows the energy supplier to be optimized with the consumption reduced, thereby cutting operating costs. Production can be monitored, adjusted remotely, and improving traceability and flexible. Final point about using technology on the factory floor is that the equipment can be monitored and enabled for more intelligence. It may be possible, for instance, to lengthen the interval between a scheduled downtime machine. This increases uptime usage throughout, leading to lower cost. Utility-size photo operations, a second possible application, involve large facilities, with these often located at significant distances from one another. Since electricity storage can be expensive, a utility must adjust what it gets from its solar cell to meet demand. This may be done by altering the tilt of the panels with respect to the sun or by taking parts of an array offline. This tuning of the application or electricity production must account for the cloud cover, rain, and other weather factors as individual locations. Combining the data from the sensors that is produced by array itself and that coming from customers or network demand provides the information needed for this balancing act. An HTML5 capable solution can access this data and the SCADA setup, forming the basis for centralized control and monitoring. The third and last typical application is factory monitoring, such as when data is using EMS. An EMS, or an energy management system, can enable significant savings, with imported consumption reduction as much as 75%. This is possible even in older buildings, as yet it implicated the latest technology. Newer buildings equipped with EMS can also benefit from the additional information generated by a swarm of IoT sensors. Taking advantage of this data, though, requires the capable monitoring and control solution, which can be used on HTML5. Advantech provides such a solution in its WebXS HTML5 Business Intelligence dashboard. It features a widget library, more than 40 different kinds of built-in widgets, consisting of such items such as real-time energy and building weather information. The library also contains data and chart displays, Google Map, alarm log, vent log, along with many other items. It's also possible to build a widget if something suitable is not in the library and create your own graphics by using Widget Builder, that is drawing tool in the WebAccess dashboard. Widgets can be assembled using the dashboard editor to a desired location. You can adjust your dashboard layout automatically or manually and set in your order shown on the phone. This can be viewed and controlled in any HDMI-capable browser on any device at any time, any place. With new data connector, Web Access Dashboard can not only get internal data from Web Access, but can get data from standard databases such as Microsoft SQL Server, Oracle, MySQL, and through RESTful API to the integration of a third-party software that makes it easy to integrate IoT applications as well as cloud devices. Dashboard is a standard function of Advantech's Web Access SCADA. This means that the data from the machines, motors, sensors, robots, controllers, and CNC systems can be accessed through display, along with the information from IoT sensors. Dashboard is configured as a result of client model and versions of Ladder available in Windows, iOS, and Android. This means that it can be used on a desktop, laptop, or even a smartphone or tablet. In the future, Web Access Dashboard will be an independent product that will continue to develop its capable and cloud visualization platform. So in conclusion, let's review. SCADA systems are used in a variety of instruments, such as electricity generation, oil, and gas production. Projections from continued growth in SCADA components are proof that technology is still valuable, but traditionally SCADA systems was designed for a given screen size. The advent of greater connectivity and proliferation of display devices make this a problem. This can be solved by putting the HTML5 technology to use because the fifth version of a hypertext markup language can properly scale what is on the display. An added benefit is HTML5 is also the language choice for IoT. Hence, it is possible to overcome SCADA's display challenges and make use of data generated by IoT sensors. This can improve your factory floor, utility, and management operations. So we took a few minutes to go through this. Once again, I apologize if I stuttered along the way, fighting the weather a little bit. So stay tuned. We will probably have, I don't know if we'll have any more yet this calendar year, might be early next year, but I hope you stay tuned and listen for ones coming up down the road. This has been Chatting with Chuck. I'm your host, Chuck, so please stay tuned for further episodes.